Hello everyone. In this video, we are going to discuss about the nodal analysis. So, nodal analysis is nothing but the method used for finding out the unknown values of voltages in a particular circuit or a network. Okay, this is a given circuit. So, here we have three unknown values of voltages V1, V2 and V3. So, we have to find them using nodal analysis. Okay. So in general, node is nothing but the meeting point of various elements. So here, the three elements are meeting together. One is a 5 ampere source, another one 1 ohm resistor and third 1 ohm resistor. So these three are meeting at a particular junction. So this is defined as a node. So for this node, we have to assume a voltage. So now we are assuming a voltage as V1. So next, this is one this is another meeting point or a junction. So here we have to assume another voltage, say V2. And this is a third junction. We are assuming the voltage as V3. So now here also we are having one more node. This is defined as a reference node. Okay, this all the elements are meeting together. This is defined as a reference node. So in general, in reference node, we have 0 voltage. So if we have n number of nodes, then we have to write down n minus 1 equation. So in that case, n includes the reference node also. So here we have 1, 2, 3, including the reference, we have 4 nodes. So 4 minus 1 equal to 3. So we have to write down 3 number of equations. Okay. So the nodal analysis is mainly based on Kirchhoff's current law. So in general, Kirchhoff's current law is states that in a particular node or a junction, sum of the incoming currents is equal to sum of the outgoing currents. Okay. So in this case, we are going to assume that currents flowing through all the resistors are outgoing in nature. Okay. So current flowing through the resistors are assumed as outgoing current, and current flowing towards the node. Okay. So with respect to current source. So if the current source direction is given as flowing towards the node, then it is considered as incoming. So otherwise it is also considered as the outgoing. Suppose if the current direction is given in the opposite way. So this indicates that the current is flowing away from the node. So this is again considered as the outgoing. But in this case, the current direction is flowing towards the node. Okay. So this is incoming current. So incoming current is written with respect to current source only, and that too if the current direction is towards the node. Okay. So now after finding out incoming current and outgoing currents, we have to equate them for obtaining the node equation. So first we'll write the equation for node 1. In node 1, we have to write both incoming and outgoing. So here 5 ampere source is connected to node 1. Again 1 ohm resistor and another 1 ohm resistor. So totally we have 3 elements. So one element is a current source and the current direction is towards the node. So this is considered as the incoming current. Okay. So incoming current is written with respect to current source only, and that too the direction is towards the node. So otherwise it is also considered as the outgoing current. Okay. So next, we have to write down the current flowing through this particular 1 ohm resistor. So this is given by Ohm's law, I is equal to V by R. Okay. So here this this 1 ohm resistor is connected in between node 1 and node 2. So the total voltage across this particular 1 ohm resistor is V1 minus V2 or V2 minus V1. That is the difference between these two voltages, either V1 minus V2 or V2 minus V1. So since we are writing the equation for node 1, we have to assume this as V1 minus V2. So this is a net voltage divided by the resistor value will give you the current. So this is equal to V1 minus V2. So next we have to write down the current flowing through the another 1 ohm resistor. So this particular 1 ohm resistor is connected in between node 1 and node 3. So the net voltage can be V1 minus V3 or V3 minus V1. So since we are writing for node 1, we have to consider this as V1 minus V3 divided by 1, or simply V1 minus V3. So now we have to add all the outgoing currents. So sum of the outgoing currents is equal to V1 minus V2 plus V1 minus V3. So that is equal to 2V1 minus V2 minus V3. So now by Kirchhoff's current law, sum of the outgoing currents is equal to sum of the incoming current. Here in this case, incoming current is 5 and outgoing current is 2V1 minus V2 minus V3. So Kirchhoff's current law equation can be written as 2V1 minus V2 minus V3 equal to 5. So this is equation number 1. Now we have to write down the node 2 equation. Okay. So again we have to write both outgoing currents and incoming currents. If you see the node 2, here we have only 3 resistors, 1 ohm, here 1 ohm and here 4 ohms. So we don't have any current source. So we can write directly as incoming current is equal to 0. So next we have to write down the outgoing currents. Currents flowing through all the resistors are assumed as outgoing only. So current flowing through 1 ohm resistor. So this particular 1 ohm resistor is connected in between V1 and V2. So the voltage can be written as V1 minus V2 or V2 minus V1. Since we are writing for node 2, we have to consider this voltage as V2 minus V1 divided by 1. So this is equal to minus V1 plus V2. So next we have to write down the current flowing through this particular 4 ohms resistor. So this 4 ohms resistor is connected in between V2 and the reference node. So the reference node is always considered as 0 volts. So the net voltage across this particular resistor is V2 minus 0. So V2 minus 0 divided by 4 or V2 by 4. So this is equal to 0.25 V2. So next current flowing through the other 1 ohm resistor. This resistor is connected in between V2 and V3. So the net voltage can be V2 minus V3 or V3 minus V2. Since we are writing for node 2, we have to consider this voltage as V2 minus V3 divided by 1 will give you the current. So this is equal to V2 minus V3. So now we have to add all the outgoing currents. So minus V1 plus V2 plus 0.25 V2 plus V2 minus V3. So on simplification, we will get minus V1 plus 2.25 V2 minus V3. So this is the sum of the outgoing currents. So now we have to write down the Kirchhoff's current law. So by Kirchhoff's current law, sum of the outgoing currents is equal to sum of the incoming current. So in this case, incoming current is 0. So the Kirchhoff's voltage law equation is minus V1 plus 2.25 V2 minus V3 equal to 0. So this is equation number 2. Next we'll write node 3 equation. In node 3 again we have 3 elements. Okay, one is a 10 ampere source and 2 1 ohm resistors. Okay, so we have to write both incoming and outgoing currents for node 3. So here 10 ampere source is flowing towards node 3. So this is written as incoming. So next we have to write down the outgoing currents. Current flowing through all the resistors are assumed as outgoing current. So first we have to write the current for this particular 1 ohm resistor. So current flowing through this particular 1 ohm resistor is voltage divided by the resistance value. Voltage across this 1 ohm resistor can be written as V2 minus V3 because this is connected in between node 2 and 3. So V2 minus V3 or V3 minus V2. So since we are writing for node 3, we have to consider this as V3 minus V2 divided by 1. So this is equal to minus V2 plus V3. So next we have to write down the current flowing through the other 1 ohm resistor, this one. So this is connected in between V1 and V3. So the net voltage is V1 minus V3 or V3 minus V1. Since we are writing for node 3, we have to consider this as V3 minus V1 divided by 1. This is equal to minus V1 plus V3. So now we have to add all the outgoing currents. Sum of the outgoing currents is equal to minus V2 plus V3 minus V1 plus V3. So this is equal to minus V1 minus V2 plus 2V3. So now by Kirchhoff's current law, sum of the incoming currents is equal to sum of the outgoing currents in a node. So now the node 3 equation is given by minus V1 minus V2 plus 2V3 equal to 10. So this is equation number 3. So these are the three equations we have obtained so far. That is 2V1 minus V2 minus V3 equal to 5, first node 1 equation. Minus V1 plus 2.25 V2 minus V3 equal to 0, second equation. And node 3 equation minus V1 minus V2 plus 2V3 equal to 10. So these are the three nodal equations. So now we can write these three equations in the matrix form. So this is the first row is a coefficient of equation 1. Okay, coefficient of V1 is 2, so 2 here. Coefficient of V2 is minus 1, so minus 1. And similarly, coefficient of V3 is minus 1. So here minus 1. So these are unknown values of voltages V1, V2, V3, that is equal to the right hand side part. So this is nothing but the current. So this is the conductance matrix, that is 1 by resistance. 1 by R is nothing but the conductance multiplied by the voltage will give you the current. Okay. So similarly for second equation, we have to write down the coefficients minus 1 plus 2.25 minus 1. And similarly for the third equation again minus 1 and plus 2. So on the right hand side we have 0 for second equation and 10 for third equation. So the general form of this particular matrix is 1 by R11, 1 by R12, 1 by R13. This is the first row. And similarly for second row, 1 by R21, 1 by R22, 1 by R23. And for third row, 1 by R31, 1 by R32 and 1 by R33 multiplied by the unknown values of the voltages V1, V2, V3 equal to the current. Okay, I1, I2 and I3. Okay. So if you see here, this diagonal elements up, that is R11, 1 by R11, 1 by R22 and 1 by R33 or the sum of the reciprocals of the individual resistors connected with the nodes. Say for example, if you see the node 1. So in node 1 we have two 1 ohm resistors. So first we have to take the reciprocals of each resistor, that is 1 by 1 and add them together. Okay, we have 1 by 1 plus 1 by 1. So this will be 1 plus 1 equal to 2. Similarly for R22 we have to take the reciprocals and add. Okay, in node 2 we have three resistors connected, 1 ohm and 4 ohms. So we have to take the reciprocals for these three, that is 1 by 1 and add them together. 1 by 4 plus 1 by 1. So this is 1 plus 0.25 plus 1. So 2.25. So this is 2.25. And similarly for third node, we have two resistors connected together, 1 ohm and another 1 ohm. So if we take the reciprocals, 1 by 1 plus 1 by 1. So this will be equal to 2. Okay, so the diagonal elements are sum of the reciprocals of the resistors connected to the individual nodes. Okay. Similarly, R12 is equal to R21. So here 1, 2, here 2, 1. So this is nothing but the common element connected in between node 1 and node 2 with the negative sign. The reciprocal of the common element connected in between node 1 and node 2 with the negative sign. So if we take the reciprocal for 1, this is 1 by 1 is nothing but 1. And we have to add a negative sign over here. So minus 1. So these two are minus 1. Okay. Similarly, R13 will be equal to R31. Okay. This is again the common element, reciprocal of the common element with the negative sign connected in between node 1 and node 3. So in between node 1 and node 3 we have this 1 ohm resistor. So 1 by 1 is 1 with the negative sign minus 1. So here again minus 1, minus 1. And finally R23. will be equal to R32. So this is again the common element between node 3 and node 2. So here in between node 2 and node 3 we have again 1 ohm resistor. So 1 by 1 is 1 with a negative sign -1. So this is how we have to arrive at this matrix. We can directly write the matrix also. Okay, this is the resistance matrix multiplied by the nodal voltages V1, V2, V3. So equal to, we have to write the incoming currents. If we have incoming currents, we have to write it as plus. So if the current source is given in the opposite way, so that is if 5 ampere source is given in this particular direction, then this current is flowing away from the node. So this is considered as the outgoing current, and here we have to write -5. Okay. So now the current direction is flowing towards the node only. So we have to write it as +5. And in node 2 we don't have any current source. So we have to write it as 0. And in node 3, again we have the incoming current. That is current is flowing towards the node. So +10. Now we'll apply the Cramer's rule for obtaining V1, V2 and V3. So this Cramer's rule is same as it applied for mesh analysis. Okay. So by applying Cramer's rule, we can directly find out V1, V2 and V3 values. So first of all, we have to find out the delta value. So delta is nothing but the determinant of this conductance matrix. So conductance is nothing but the reciprocal of resistance. This is reciprocal of the resistance, so nothing but the conductance. So we have to find out the determinant value for this particular matrix. So 2.25 into 2 minus 1 plus 1 into minus 2 plus 1 minus 1 into 1 plus 2.25. So on simplification, this value will be equal to 0.75. Okay. So next we have to find out delta V1 value. So for finding out the delta V1 value, we have to replace the first column by the right hand side matrix. So here the right hand side matrix is 5, 0 and 10. The remaining two columns will be the same. -1, 2.25, -1. Here -1, 2. Okay. So now we have to find out the determinant value. So 5 multiplied by 2.25 into 2 minus 1 plus 1 into 0 plus 10 minus 1 into 0 minus 10 into 2.25. So on simplification, this value will be equal to 50. Okay. So now V1 is given by delta V1 divided by delta, which is nothing but 50 divided by 0.75. So this will be equal to 66.6 volts. So now we'll find out delta V2 value. For finding out delta V2, we have to replace the second column with the right hand side matrix. So first column will be the same. Second column is 5, 0, 10. So third column will be same. Okay. So now we have to find out the determinant for this. So 2 into 0 plus 10 minus 5 into minus 2 plus 1 minus 1 into minus 10 plus 0. So on simplification, we'll get 45. So V2 is given by delta V2 divided by delta. Delta V2 is 45. Delta value already we have found out 0.75. This is equal to 60 volts. So next we have to find out delta V3. For finding out delta V3, we have to replace the third column with the right hand side matrix. First two columns will remain the same. Okay, third column 5, 0, 10. So we have to find out the determinant value. So 2.25 into 10 plus 0 plus 1 into minus 10 plus 0 plus 5 into 1 plus 2.25. So on simplification, delta V3 will be equal to 51.25 So V3 is delta V3 divided by delta 51.25 divided by 0.75. So this will be equal to 68.33 volts.